Atmospheric Science students, this is Dr. John Schragi, and before we get started with Module 5 and the Stephenson lecture associated with it, I thought I'd just continue my pattern of telling you a little bit about all the Linux computers that are in your life and you didn't even know about it. I mean, we've talked before about things like Android phones, we've talked about Roku devices, we talked about routers and so on. Thought I'd just show you here. I got a beast of a printer here. Oh, I think I paid a big $110 or something for this laser printer some time back, and it's way too big, and I don't really need it that much, but when I need it. And it's got some smarts in it, of course, as all devices these days do, and it can do things like print things from the cloud for me using Google Cloud Print, and it is able to be printed from any of the computers in the house and so on. And so obviously it has some ability to be monitoring the network and figuring out when printing is happening and so on. It has to have a computer inside there to be doing those things. And you know what? They could have put any kind of computer chip in there, and they could have put any kind of operating system on that computer chip, but you know the pattern by now. It's Linux. They actually have a little Linux computer in here that's running this thing. Why? Because it would run on, I mean, the printer doesn't have to be fast in terms of like how much it has to be monitoring the network and things like that. They put a very cheap chip on there, and it isn't that hard once you've got a chip in there to get Linux running on it. And so they happen to be running Linux, and I can tell it's actually a computer running Linux. If I mess around here with the menus for a little bit, I can get the printer's IP address, and if I put that into a browser, that's in fact how I manage the printer. I mean, I can actually put in here, at the present time on my dynamic network, it's 192.168.1.112. It doesn't really matter, and I can get things in here like messages like it's telling me the toner is low, and I can go over here and I can actually set things like permissions for scanning. I don't know why I would ever do that, but if I was maybe in a business, that might be something I'd want. I can, add more devices. I can upgrade the firmware, things like that, all from this little interface. That's just on a web browser. And you know how I know that it can do it? Because that little Linux computer in there is running a web server, like Apache 2 or something like that, just like Chesapeake is, and actually just like the router was that we learned about last time. So, I mean, here's another case. They don't advertise that it's a Linux computer, but it is a Linux computer with, and I'll bet money, if we knew how to do it, we could actually hack into this thing from our SSH or our PuTTY, depending on how you're doing it on a Mac or a PC. I bet if we knew what we were doing, we could get in there, and it's probably got things on there like VI and GCC and all those kinds of tools that we're used to. I don't plan on trying to hack my printer anytime soon, but I bet we could do it. Anyway, and it's got a little web server on there, and it has little other software programs on there that are monitoring the network and communicating with Google Cloud Print and so on. Alright, another example of a weird little Linux computer in your life you didn't even know was out there. Alright, well now we're going to move forward and talk about Lecture 5. Okay, we're we're back. And let's talk about this reading from the Stephenson book. About the name of the chapters were Morlocks and Away at the Keyboard and Metaphor Shear. Let me just kind of have it up here and let me talk to you about this stuff here. This idea of metaphors is very key to the idea of how graphical user interfaces, or GUIs, work. They make it easy to work with complicated ideas if you take on certain assumptions and certain simplifications and certain biases and so on. It used to be that you sat down in front of a computer and you had an interface very much like what we work with in Chesapeake, where you had command lines and you had to know stuff to make anything happen on the computer. But over the course of the last 30 years or so, computers have increasingly been built around metaphors that make it much easier to understand how to use them to accomplish work, but they force certain assumptions and certain simplifications upon us. A good example of the kinds of metaphors that Stephenson is talking about here are things like the desktop, or documents, or the recycling bin. Okay, there's nothing recycling about the recycling bin. It's an idea. You have the idea that if I put a document into the recycling bin, it's gone, but I can get it back. Okay, that's a whole lot of not quite understanding what's going on, but you don't really need to. I mean, even somebody who's not very good with computers probably can figure out that if they put something into the recycling bin, it's gone. Never mind what is putting something into the recycling bin, understanding how to use the mouse to make that all happen. I mean, we've all been so trained by the last 30 years as to how to do all of that stuff. But that doesn't mean that all these metaphors make sense, or that all of these metaphors are self-consistent and so on. The book actually talks about what a ridiculous thing this whole idea of save is. I mean, save is in many ways the worst metaphor in computers. When you are ready to make changes to your document and then you hit save, what actually is happening here? I mean, when you go down here and you hit save, you have made changes to your document. What happens to the old one? Well, unless you have fancy like version tracking software installed on your computer, what happens to the old version of the file is it is gone. Okay, there are ways to recover it and so on, but generally speaking, a better word for save would be destroy the old and put the new there instead. Well, that doesn't really roll off the tongue the way save does, right? We all have this idea that save is kind of a two-edged sword, right? I mean, if I've made changes to some spreadsheet and then I don't save it, well, sometimes that's not, I mean, I wanted to not clobber the old version. Oh man, I am the king of doing that. I'll have taken some old version of a PowerPoint, and then I do a whole bunch of stuff to it, and I mean to save as version for this calendar year, and then I forget and I've clobbered the old one. Okay? Save doesn't really mean save, it means stomp on the old version. That's not the same thing as save at all, yet somehow or other that's what we've come to understand. And there's lots of other examples of these metaphors where it doesn't really mean what we think it means. I mean, open. What's opening when you open a file? When you open a file, what you're really doing is going to that location on the hard drive or wherever and pointing to it, and then maybe reading that file in and putting it to memory the way you would like in a Word document, or like in a C program you might be reading in a certain number of floating point numbers or something. But what does that have to do with open? How is that opening anything? But yet we have this idea, I've opened a file. Okay? Print is kind of a metaphor as well. I mean, there's not really any printing going on or anything like that. The book is a bit snarky in mentioning that help can be kind of a metaphor. Often the help file is no help whatsoever. But certainly things like the icons on the desktop, I mean, we associate in our mind that this icon does something. The icon doesn't do anything. It's a symbol that when we double click on it, we activate certain actions inside of the computer. But I mean, it's just a tool. We could have had something else. The desktop, of course, being an example of a metaphor. There's nothing desktop about it, but with this idea that this is a space and we can put things on that space that are current to what we're working on and so on, it's a metaphor. It doesn't have anything to do with how the computer really works. It's just a metaphor. I don't know if you know, on most computers, the desktop is actually just a folder. Okay? That used to be a huge secret, but nowadays I think both Macs and Windows actually make it much more clear that you could actually go to the to the desktop folder on your computer. These kind of interfaces and these kinds of metaphors certainly make new inventions relatively easy to learn and make them relatively useful fairly quickly. It's hard to imagine how much harder it was to learn a new device back before we started having more and more of these kind of consistent interfaces in front of them. That's part of the reason why learning how to drive is hard, right? The interface that you have in front of you when you are driving a car, the steering wheel, the pedals, the shifter, all the different gauges and knobs and the turn signals and everything, all the knobs on the controls over here are all kind of different from what you use in your day-to-day life. That's why you have to go to driver's education, because that's hard to learn. But the interfaces also make it possible, right? The book talks about the fact that, for example, internal combustion engines were pretty much useless toys for thermodynamic scientists until somebody attached them to an interface of things like clutch, steering wheel, pedals, and so on, that made it something someone could use. You need the interface unless you're going to be an engineer about the whole thing, okay? But all that technology, all that interface was kind of the technology of the time. Cars came into being right near the end of the era of like buggies. Okay, which is why we have a dashboard. Okay, the dashboard was part of a buggy. It was the board that was in front of you that like you could put your feet up on and so on. Big wheels like a steamship, a lever for the emergency brake, the way the lever held the brake on a Conestoga wagon or something like that. All of those interfaces, are the big pedals that also used to push down certain brakes and so on. All that comes to us from like the late 1800s, okay? And we still use those interfaces today. We wouldn't have to. We could have like fly-by-wire cars the way we could have, in theory, fly-by-wire airplanes, where we replace the interface of things like wheels and gear shifters and pedals and all this kind of stuff with electronics. Okay, I kind of like this old school electronic self-driving car thing that they got going on here. I've had a time though in a period of life where I had a car with a laptop in there, but I didn't really have anyone sitting in the passenger seat. Anyway, you could do this. We could design a car where we had a different interface, where maybe you use the left and right arrow keys to navigate left and right. That wouldn't be very much better, would it? Or maybe like you could use the trackpad on your mouse to like move forward and side. No, that really wouldn't be better than the wheel, would it? But you could. You could. And in fact, by the way, there's a huge push to make fly-by-wire the way things work in the cockpit of an airplane, and pilots hate that. Okay, there's all this instrumentation that they're just glass, you know, they're flat panels, but they're made to look like old-fashioned needle gauges and things like that because that's how pilots learned. That's how they want it. That's the experience of flying. And in fact, pilots fight it so much that you can actually, if you snoop around and look at an airplane, there are still pieces of old technology there, like the yokes and so on, that the pilots are pulling on. So even though that's just hooked up to computer electronics that then, you know, relay a signal back to the servos that run the flaps and things like that, they're not really moving anything when they move those the yoke and so on anymore. It's all fly-by-wire, like on a commercial airliner, even though the pilot hates that. Interfaces, as I mentioned before, always reflect the technology of the times. You know, clutches, emergency brakes, pedals, big wheels, that's all like late 1800s technology. Let's not worry about the airplane controls so much as how about, like as your book was talking about, the controls on an old VCR or even an old DVD player or something like that, where that weird mix of buttons and some on-screen programming and things like that, it's all technology of like the early 90s. There's a reason why those technologies look the way they do. When you go to the grocery store and there's those card readers that you swipe your card to pay at the end, I hate the fact that there's a mix of a keypad to put in your PIN and a touchpad to say, okay, and do I want to get cash back and so on. Well, it's just two different eras of technology, right? I mean, people originally associated using their card on a machine with like ATMs, where you touched and you hit physical buttons to enter your keypad. But they also want to make choices on a screen that, you know, the grocery store chain also puts other messages on there like advertising and so on. And that's going to be touch screens. Okay? It's weird how they combine, anytime somebody has an interface where it's got both physical buttons and touchscreen, it annoys me. It's two very different eras of technology overlapping with each other. Now this particular semester we haven't been using any weather visualization, commercially available weather software, but we sometimes do. And like the surface that we typically were using before was WXP, which is a command line interface, menu-driven type software package, where you would enter, like, it would give you, enter 1 for United States, enter 2 for the United States Smooth region, number 3 for New England, number 4 for the Atlantic, number 5 for the southwestern United States, etc. Well, these menus are in here. This is what computer programming looked like in like the 80s. Okay, when you got an old 1980s text-based video game, you know, Oregon Trail or something like that, you know, press 1 to feed the oxen, press 2 to churn the butter, press 3 to get your smallpox inoculation, whatever. It was just menus, okay? And WXP is still a commercially available weather product. If you go work at a television station or if you go work for a consulting company, there's a pretty good chance that WXP or something very similar to is what you're going to use, and it's still written that way. Now, gosh, like 20 years ago, I was involved actually with the WXP team to help make the interface for a graphical user interface as well. And oh my word, the graphical user interface was this hugely complicated set of buttons and push downs and dialog boxes, and it was a huge mess. Okay, because what WXP software can do an awful lot of very technical things. We wanted the users to have control of things like contour intervals and the colors and the regions of the map and how smooth the contours were and so on. And we ended up with this ridiculous interface that I'm only showing you for how bad it is. And by the way, you'll actually notice here there's a button on this is the less options mode. When you push the more options mode, TKWXP expands to take over the whole screen with dialog boxes. Okay, No wonder everybody hates TKWXP. Again, if you go out into the workplace, I was one of the people behind TKWXP, and I can tell you it's hated. Because there's just too many buttons, too many controls, too many layers, too many... It's impossibly difficult to work with. Okay? It's a product of its time, though. You know, this was, you know, when the more features, the better. The more features is what sold software, not how easy it was to use. All right? But, you know, the book talks about the fact that appliances like VCRs or microwaves have to have an interface, too. You know, they've got little buttons there that can do all kinds of surprisingly complicated things. If you didn't ever notice even like a $70 microwave from Target has all kinds of fancy features for defrosting by weight, defrosting by number of servings, reheating by weight, reheating by number of servings. It probably has a whole list of pre-programmed, you know, cup of coffee, cup of tea, popcorn, that kind of stuff, microwave burrito, all that kind of good stuff. All of which it runs off of that tiny little screen with the little LEDs in there. Our microwave that we have here in the house has all kinds of like happy little greetings it gives you when you're done with your food. Please enjoy your meal, okay? Or if it's morning, enjoy your breakfast. Who designed this, okay? Well, I mean, let's face it. The main thing I know how to use in my microwave is the little button that says 1 minute more. And if I need to cook something for 30 seconds, I push the 1 minute more button and I stand there and wait, okay? I don't know how to use all those dumb features. I grew up in a house that had a microwave more like this, where there was just a knob. Okay, you turn the knob how long you wanted to cook. There weren't any other features or anything on there. You just turned the knob and then you stood there until your food was done, and the little timer bell went off. My grandparents actually had a microwave very much like that that didn't turn off when you opened the door. Okay, it would literally, the magnetron would still be running. You could cook your hand going in there if you didn't stop the microwave, turn it to the bell at 0 before you turn off. Okay, there was almost no interface to this thing. Okay, the interface makes it easier to actually use something, and you don't even have to learn all those features. I mean, it's okay to just learn the very basics if all you're trying to do is something simple. If all I'm trying to do is warm up the baby's milk, I know you're not supposed to warm up baby's milk in the microwave, but we do it all the time. If all I'm trying to do is warm up the baby's milk, the 30-second more button is perfect. I don't really need to know that there's a reheat beverage menu deep in the mode settings, reheat beverage. I could set it to how to heat up a baby's bottle. I don't care. Okay? I don't even like the fact that my microwave says, please enjoy your beverage when I'm done. I certainly don't want to have to be dealing with all those menus here. Well, why do the manufacturers put all this crap in there? I can't imagine very many people dig around in the menus to set things like the average number of ounces of a beverage they're going to reheat. Despite the fact that I'll bet your microwave you got in your dorm room or whatever can do that. Why do they put that there? Because it's a feature. Even if you never use it, selling a product like that requires a list of features. There has to be something on there that when you go and you're trying to decide this microwave or that microwave, that makes it different. Even if you never use that thing, it's one more bulleted point on the list. It was worth the engineer's time to put that one stupid more feature in there. Guess what? Nobody really cares how much. Microwaves are a zero-profit industry, okay? Nobody's making any money off microwaves anymore. All right, you can buy a perfectly good microwave for $70 not on sale at Target. You can probably get it for $30 on sale. Cell phones, on the other hand, yeah, somebody's making a lot of money on that. They're called Apple, okay, or Samsung, all right? And they have an interface on there. And your cell phone can do a whole lot more things than your microwave can, okay? It's a computer. In fact, it's a very good computer. In fact, it is probably a significantly larger computer in terms of its, its rates and things like that than your laptop, probably. Okay, it's probably the most important computer you have in your life. You're probably either running Mac iOS, or you are Apple iOS, or you're running Android. I'll just talk about Android just because that happens to be the one I have right here. Of course, as we've talked about before, it is a version of Linux. And why? Because Google makes a version of it called Linux for free that they call Android, and anybody can get a copy of it. And it is a version of Linux, and you can kind of tell it's a version of Linux if you dig around a little bit. I mean, with a little digging around on your phone, you can find things like the file manager, for example. Where's mine? File manager, there it is. And you start seeing, oh, look, I mean, I've got files, well, they're kind of in little groups here, but if I start messing around, oh, I see, wait a minute, I've got a file called internal storage, and in there, I've got storage, I've got folders like, well, they look like the names of folders that are actually on Chesapeake, come to think of it. Things like Lib and Users and Home. Yeah, that's because it is a Linux computer. Chesapeake's a Linux computer, and so is my phone. It's not surprising. And they don't actually ship Android phones with things like GCC, but you can download it. They don't ship them with things like VI, but you can actually download. You can get VI for your cell phone. I don't know why you'd use it, but you can. Some of them you have to have root access in order to do those things. By the way, root, that's also how you access the system settings on Chesapeake as well. You have to have the root access, just like you have to root your phone. But there is no command line interface unless you install one on Android. They don't make it possible for you to go in here and type CD space my phone contacts or some folder that you happen to have in here. Okay, they don't give you that ability, despite the fact it's a Linux computer. It can do that. They just don't provide that to you so you don't mess it up. This is a relatively straightforward interface. Okay, if you're an Apple person, Android always looks like a mystery. If you're an Android person, iOS always looks like a mystery. But I mean, I think we all understand the basics of this little interface. Things are pretty much always this sort of a certain way. And it's adequate. What do you mean by it's adequate? I mean, it gets me do pretty much all the things I really needed to do. Alright? I'm going to make a call. I hit the picture of the phone. And look, a keypad here shows up that looks pretty much the same as like every phone I've used since I was like 10. Okay? I want to send a text. There's a little picture of a text person thing there. And when I push it, I get a little keyboard. Even my mom is the queen of sending texts here, despite the fact she doesn't know anything about the interface on her little iPhone color thing. This relatively basic interface on what's a very powerful computer is more than adequate because nobody's doing anything all that complicated. I mean, as long as all you're doing is making a call, boop, hit the button there, it's pretty darn good. That's really all you need. Making popcorn? Push the popcorn button on your microwave, not on your phone, on your microwave. Yeah, that's it. You're just going to record 24, I don't know why I put a 10-year-old television show on there. Your VCR is fine for that, okay? It's only if you're trying to do something complicated that suddenly these very crude interfaces don't really work so well. By the way, that is at the core what it means to be an app. The word app kind of annoys me, because apps are a fairly specific thing. Nowadays, because the word app is such a thing, Word wants to, they're a word processing app, and Excel is a, spreadsheet app, and think, no, you're not. An app is something very different. An app is, at its core, a very simple application, a program, that does one simple thing. If I go here into an app on my phone, heavens, I'll go into Word for Android. This is an app. There's a whole lot of things that you can and can't do in Word for Android. But basically, all you can do is pound in some text. You can't run the equation editor, you can't run the image editor, you can't make tables, you can't change you can change the font to like 8 different system fonts. You can't change it arbitrarily to anything you want. You can't adjust the margins of the pages, etc. Basically, you can pound in text, and then later upload it to where, to your OneDrive account or whatever, and edit it. Same with PowerPoint. I actually use PowerPoint on my tablet a fair amount, but actually all you can do is basically pound out text and put images in. Anything fancier like animations or annotations on the slide or any of the fun things I love to do on PowerPoint, can't do that on there. It's an app. Okay? Most apps are pretty simple. A flashlight app. iFart. Yes, that's all. Apps are simple little interfaces. They're the equivalent of the make popcorn button on your microwave. Okay? That's different from an application, which could be, menus and commands and buttons and files and folders and managing your own files and all this kind of stuff like, Photoshop or something, okay? That's the difference there. That is kind of a way we use the words wrong. We only really get in trouble with this idea of these very simple interfaces like the popcorn button or the phone button on your phone or whatever when you try to apply a simple interface to a complicated task. That's when you suddenly start realizing there's a whole lot more going on behind the scenes that you don't know how to make it work because you've been using it with this metaphor. And the author got really wigged out about the whole thing that he called metaphor shear. He said, but you probably read the story. You saw how he had written some documents in an old version of Word, and then had an old stack of floppies someplace or something. And then, you know, maybe 10 years later he wanted to read them, and he found out Word 6 couldn't read the Word 1 files. Oh, that used to be a big problem, that they couldn't do those kinds of things. And suddenly, all that stuff that he had done that seemed very real, you know, where he had done things and put ideas onto pixels, suddenly was gone. Because he had just learned this interface. He had just learned these metaphors. And he had never actually thought about it in terms of what those ideas are. You know, they weren't permanent, they weren't indelible the way like ink is on paper. Once he didn't have a working copy of Word 1, those files were as gone as if the house had burned down and taken those disks with it. Okay? We won't worry about that part right there. He had pictured his documents symbolically. He had thought of them as words and ideas and tables and thought and communication, but, you know, as in these things were more than just the sum of the letters of the alphabet. But they really were just ones and zeros on a binary plate spinning around inside of a plastic case that was the floppy disk. And without the right decoder, you couldn't do anything with them. This is a danger of when you're working with metaphors and codes and so on. And this is actually a big, big problem in meteorology. This is the problem known as bit rot. Bit rot, I mean, there was nothing wrong with Stephenson's files. The problem was he didn't have anything to read it anymore. There was no longer a working program that could read Word for Windows 1 files. We have this problem all the time in meteorology. If you want to get out the radiosonde observations from Omaha in the 1930s, well, here's the problem. We've changed the codes. Like, I think currently we use buffer as the code that is how they actually encode observations that come from radiosondes that are launched in the United States. And prior to that, we used a code called TTAA, TTBB. And prior to that, we used a code that was called, oh gosh, what was it even? SAO? No, that's surface code. I can't remember. Anyway, the point is, by the 1930s, that's probably 6 or 7 different sets of code ago. Nobody has any documentation anymore as to how you actually read it. Yeah, you can get the information, I'm sure, sitting someplace there. There is a, you know, an old magnetic tape or something where they've archived that data, but how do you read it? And the same is true of, like, METARs, okay? METAR, the code that we use for surface observations, that's a relatively new thing. Prior to, about 10, 15 years ago, we used a code called SA. And prior to SA, we used a different code. And you know what? If you have a whole bunch of observations that are in SA format, where are you going to get code to read the thing? You'd probably have to write it yourself. And you'd probably have to go dig around at like a historical library of meteorological documents to find out even how SA worked. Okay, and it probably has references to like code numbers on tables, but there's no such copy of the table anymore. Oh man, this is actually a big problem. NASA has this problem a lot. Their imagers that they launched in like the 60s and put into orbit around Venus and so on, this was before formats like JPEG and things like that existed. They made their own formats. And then that data sat on a, you know, magnetic tape someplace for 40 years. Well, so when somebody wants to go and access those images now, the problem is no one has the slightest idea what these files are. How do you use these ones and zeros that are on this disk to actually reproduce and produce an image of Venus from the orbiter that we put up there in 1966? Oh man, science in general has big problems with bit rot. This idea that we forget about what the formats of these files were and we move on, and then when we go back, we don't know how to work with that data anymore. Alright, well that's the end of this Stephenson lecture, and we'll talk more about his stuff at the beginning of the next module. Please let me know if you have any questions. This has been Dr. John Schrage.